Hey, so today I'm going to try something different. I'm just going to keep it casual and we're just going to talk. So, my topic of discussion is lighting. Lighting is insanely complicated. Like, you would think it's very simple. You just put some light bulbs or, some LEDs on a wall and call it a day. Well, there's way more to that. And as I get like new designers or engineers involved in lighting design, they can get completely overwhelmed with everything that we have to do. So it's good to just take a step back and just talk about a subject from a high level. Then you kind of get the idea of, oh, these are all the things I got to do. And then when you do your small pieces of it, you understand how it fits into the whole picture. So today I just want to discuss maybe a couple things. We're going to talk about light fixtures. We're going to do the light calculation, or we're not going to do the calculation. We're going to talk about the calculations, how you pick like a lumen level and the distribution. Then we'll go into how to power up your fixtures and then how to control them. So let's just keep it simple today. All right, so first off, we're going to talk about the fixtures themselves. Light fixtures are anything that produces light. You can have them inside or outside in an explosive environment. You can put them in a wet location. They come in hundreds of different sizes and shapes, maybe thousands actually. So you have to pick one that suits your needs. And some of these common terms that you'll come across are troffers or recessed lights. These are things that go into the ceiling or into the wall or into a cove. These fixtures, they don't stick out very much, and they're good to make the room appear seamless. Like you see these up here, these are not recessed. These are called suspended lights. So sometimes when you have suspended lights, they can be chain hung, they can be stem mounted, and the chain, swings around, the stem is more rigid. These are rope hung, I guess. they have a rope that just has wire wrapped around it and they're just suspended there. But then you have these lights over here, which are just LED accent lights. So you have all different kinds of fixtures. And there's certain names to them. So a couple of them that I personally never knew until I got more involved. High bay fixtures are any fixtures that are mounted higher than, 10 or 15 feet. We'll say 10 feet. To me, in my mind, anything over 10 feet tends to be a high bay fixture. They're more powerful. They're meant to be mounted higher, such as warehouses and big open spaces, shelf spaces sometimes. And they provide a huge cone of distribution. So those are high bays. And then on the other spectrum, I've never heard of sconces before. So sconces are things that you mount on the wall, and it's more like a decorative light, more than a floodlight kind of thing. So you'll see them they're just wall mounted at about, let's say anywhere from 6 to 8 feet I've seen, and they could have a glazing effect where they light up the whole wall on the side, or maybe they'll wash down the ground, or maybe they'll wash up. And sometimes people go for the scalloping effect, which is where the light kind of does a cloud shape. It's it has that bubbly look on the wall. Some architects and lighting designers like that. So, and then what else was there? Oh, bollards can be retrofitted with lights too. So if you don't know what a bollard is, it's a big post in the ground that's supposed to protect pedestrians from vehicles or any moving thing. If you have a sidewalk next to a busy street, or equipment that's near roadway, you'll typically put bollards nearby so that anything that could run into said person or equipment will be stopped by these bollards. And these bollards can have lights on them, and the light can spill out in a circular pattern, or you can do different distributions of them. So yeah, there's so much to go off of. You have what else? What's another good one? I think step lighting is good for putting it in the steps. You have recessed cove lighting, which are really good for accenting the perimeter of the room. There's other terms like direct and indirect light, which it's light that is shining directly on your surface, or an indirect meaning that the light will shine like up at the ceiling, bounce off of the ceiling, and then light the rest of the room. So I actually really like those, the indirect lights, because it just lightens up the room so evenly without any glare. Let's say another one is downlights. So downlights, also known as like can lights, they're typically round, but they can be like squared or something, and like you usually find them like in a 6-inch diameter. So they go into the ceiling, whether it be tile ceiling or hard ceiling, and they just produce like a little round cone of light on the ground. Those are usually like in office spaces or like homes where you want like a nice warm fuzzy feeling kind of place. It's trying to like tone down the industrial feel of a space. The only downside to them is that they don't really have they don't have the best distribution, let's just say, and they look nice, but you'll have to do a lot of calcs to make sure that you don't have like dark zones or your ceiling doesn't look too dark. So that's a lot to take into consideration just for like the size and shape of the fixture. Then you also get into classifications, which are like your class 1, div 1, class 1, div 2, where things could explode. So you want to make sure that the fixture basically doesn't have any hot spots on it. So like if a fixture is rated for class 1, div 1, that means that under normal conditions, the environment that it's running in is explosive in some sorts. Class 1, I believe it's like gas, so like explosive gas. Class 2 is dust. So if you have like saw or like fine grains of sand, that's a class 1 that's a class 2 situation. And then like class 3 is like flyings. Yeah, they're called flyings. So basically it's a little bit bigger than dust, but they're like just hanging in the air, such as like a clothing factory where they make fabric. You can have like little pieces of fabric floating around. That's, could be explosive. And the purpose of rating your fixture for that environment is so that there's no part of the fixture that these things can settle on that'll reach a temperature that could explode or catch on fire. And these fixtures are typically sealed off so that things don't get in the fixture and also cause the same problem. Fun fact, if you do have like a light fixture that caused an explosion, especially in a class 2 or class 3 environment, there will be a follow-up explosion because the first explosion will knock all the dust off of all the light fixtures and all the surrounding area, and then the second explosion just, knocks your socks off. So it's important to make sure that your fixtures are rated properly. Then there's also the wet and dry location. So obviously if you're going to put a fixture outside, it should be outside rated. If you're putting it in like a shower room or like, a sauna, it's got to be wet location rated. It has to be sealed. Clean room fixtures are very heavy duty. You want to make sure that those have gaskets. They're made of like very sturdy stainless steel or certain plastics that are resistant to like chemical cleaning agents. Let's see. Yeah, I mean, that's probably enough for the fixture types themselves. So as you can see, there's so many different varieties of like shapes, form, function, and location of the fixtures. So just picking that alone is a job and a half by itself. All right, so now after you've picked your fixture, you have to typically select a lumen level. And what that means is you have to pick how much light comes out of that fixture. And you also have to pick how it comes out of that fixture. So the light levels are specified as lumens. And you could see something like 1,000 lumens or 2,000 or anywhere up to like 20. I've even seen 100,000 fixture or 100,000 lumen fixture. Like those were like stadium lights. They're insane. But your typical room light it's probably like 700 to 1,000 lumens on the high end. So these lumens help you calculate how many foot candles you get on a surface. So like normally when you have a lighting design, there's a lighting criteria that you have to meet, illumination levels. So the illumination levels specify what height that you are measuring from. So like in a corridor, we typically measure like on a floor, but in a working space, like an office space or something, you want to measure like 30 inches off the ground because that's about the height of a tabletop. So that's the surface that you're worried about. And if you have like something that like varies a lot, like if you have actually, you know what? Let's not get into that. That gets too crazy. But let's just say floor and tabletop. Those are your two measuring surfaces. You will run that through your calculation. And for calculations, you would use like a lighting software. I've used Elam Tools a lot recently because that integrates well with Revit. There's also, I think, AGI 32. There's Acuity Visual, I think. So, I mean, there's a whole ton of lighting calculation software. I mean, that alone could be its own video. But the bottom line is that calculation software takes an IES file, which shows the photometric of a light fixture. So the photometrics is like, it kind of looks like a weird shaped balloon in a way, in that it shows you how the light comes out of the fixture. Sometimes you'll have like a nice like wide distribution, which, you know, is like, you know, a type 5 maybe. Oh, which is another level to it. So distributions have type names. So like a type 2 is like a long and narrow. Type 3 like pushes out a little bit. Type 4 is like super wide reaching. And I think like type 5 is like omnidirectional, like it goes completely around the fixture. That's usually for like site lighting. Interior lighting don't specify type distributions as much. So like if you had just a like a 2x4 in the ceiling, a 2x4 troffer only has one type of light distribution, so you don't have to worry about it. But the software will take all of that into consideration when you input the IES file for the fixture you select. So you pick your fixture, you take a guess on your lumen levels first, you pick your IES file, and you stick it into the software. And in the software, you have to spell out how high you want the fixture to be placed, give it its room dimensions, and then you can specify like the reflectivity and absorbance. So like if you have, let's say you're in a very white room, everything's white, and you have stainless steel, like that makes a big difference on your calculations versus if you're like in an art gallery where the walls are painted like a matte gray, you have curtains, you have no windows, you know, that's a huge factor in your lighting calculations. So you run all of these things through the lighting software and it spits out like a foot candle level, and it gives you average, it gives you min and max, it gives you like the whole distribution, and it gives you like sometimes like a map with like the contours around it showing you where the hot spots and where the dark spots are. So then you would evaluate all of that, and then you decide if your fixture placement is good, if your light level selection is good, and if your distribution is good. So you keep playing with those three things until you get something that is nice and evenly lit with the levels that you want. And you check for glares and hot spots on the walls. You check for scalping effects if your fixtures are too close to the walls. So you can get really into the weeds with the calculations. And I remember doing a lighting calculation for a what is it called? Like a auditorium. Yeah, that's what it was. It was an auditorium that had like tiers, and they had stage lighting, and they had all kinds of crazy stuff. And I kid you not, I think I did that for a month. Like we were doing, and it also included the outside too. It was like a theater. Oh, it was like a theater. That's what it was. I did almost 10 years ago. But this theater had so much lighting going on that I would do the inside and the outside, and then the client would say something about it, or the architect would have to say in it, or they would change the shape of something, and I'd have to redo the calcs again. It was kind of crazy. But I spent so much time on that, but it was also kind of fun because I can see like the renders of it, and you can, you have so much to play around with. It's more of an art than a science at that point. So it's pretty interesting, and we'll get into that discussion one day. So yeah, let's move on. The next step is to power them. So let's see, powering fixtures, it could be really simple. But it can also get super complicated. So let's just say normal power. You just take, typically for the United States, it's 120 or 277 volts. It's very rarely do I ever see 208 volts. I'm not even sure if it's rated properly for that, but it's a single phase power to your lighting circuits. And LED fixtures have gotten really efficient to the point where you could put up like 100 fixtures on one circuit if you wanted to. But keep in mind, these are continuous loads, so you have to make sure you account for it by multiplying your load by 1.25, and it still holds a lot. So like if you were at 277 volts with a 20 amp breaker, you can, be well over 2,000 kilowatts of power. So yeah, you're gonna cover like an entire floor on one circuit, and it's not generally good practice, because let's say you need to go and add a light fixture or replace one in one room. Well, now you're shutting down the whole darn floor, and it's not the best way to do it. I typically don't do more than like 4 to 5 rooms per circuit. If it's a big room, then I might not go more than 2 rooms. Or sometimes in a room, I might throw in 2 circuits, just for redundancy purposes. So like if you trip a breaker, you don't want your entire east wing of the hospital going out. It's not a good design. So your lighting panel has a lot of circuits. It's all single phase, so you can use a lot of poles. Split your rooms up. So like if, 5 rooms, put them on one circuit. The next 5 rooms, put them on another circuit. If you want to, you could stripe them. So that's just how you can circuit them up. Now, as far as the type of power you want to take to your lights, kind of depends on how you want to handle your emergency system. So normal power is very simple. You just take normal power to your light fixture, and it powers it up. Your emergency power is for egress lighting. So egress lighting is required from NFPA 101, and that dictates that you need to have lights that come on at least within 10 seconds and remain on for at least 90 seconds to satisfy your code requirements for egress lighting. Okay, future John editing this, I meant to say 90 minutes. Why would you want 90 seconds worth of time? Yeah, whoops. There's other stuff in there, like your average foot candle, I believe, has to be at least 1 foot candle, and your minimum is 0.1 foot candle. So, I mean, you can read into that if you want to, but let's focus on the power part. So the power you can bring are you have 2 sources for emergency power. You can do battery or generator. And I'm simplifying the battery part. Let's just say you can combine lighting inverter and integrated fixture battery. We'll just put it all into the battery category. So the batteries are great in that the fixture turns to emergency power like pretty much immediately. Like you won't have a delay where the room is entirely dark. The batteries will require replacement, testing, maintenance, all that good stuff. And you can put all the batteries in one location using an inverter, or you can have it distributed throughout your building, having like each fixture have its own battery. There's pros and cons to either one. So like the combined location one is nice for maintenance. Everything gets serviced in one location. But if you have a failure at the inverter, all your lights are, affected. Whereas the other method is kind of like a distributed battery method. If 1 or 2 fixture has a problem, your whole facility is not going to be having a problem. But the maintenance is going to be a lot more work. You have to go to each fixture to test them and make sure that the batteries are good. So you can do it that way, and that'll meet your egress requirements. You also have to pay attention to where your egress path is. So sometimes I put more fixtures than I need to. You really only need egress lighting where the architect has dictated your egress path. So if your egress path doesn't go through like a particular room, that particular room technically doesn't need egress lighting. It's nice to have, of course, but like you technically don't need an egress lighting in a bathroom. Like in a single person bathroom or janitor closet, you don't need egress lighting. And that's a good thing because it's not that cheap to put egress lighting in. So if it's in the fixture, you still got to buy the battery. It's an extra adder. If you're going to go the generator route, you're probably going to need a relay, and you're going to have more complicated controls. So that gets more expensive that way. But yeah, so only put them on the egress path unless specifically requested by the owner to add more. I mean, there are some good instances where you probably want to add, like for instance, in the shower, the locker room and the shower room. So the shower side, I've always tried to put at least one egress fixture kind of like in the middle. So like if you lose power, you're not gonna be completely in the dark in the shower. It's probably not a good thing. Sometimes if you have like machinery room, for instance, like if you have like I don't know, a bunch of saws in a room, when you lose power, the saws don't stop right away. They still go for a little bit. Or like if you have a mixture going, sometimes a big motor can actually take a while to spool down. So if you lose power, you don't want to be completely in the dark. So it's kind of just like a logic design kind of thing. If it makes sense to put it in there, maybe put it in there and then check with the owner, make sure that they're okay with paying for that. There's like certain very few areas of the code where it's like absolutely required. So you got to make sure that those are met, but then anything outside of that is kind of a nice to have. Wow, I got a little off topic here. So we're talking about battery versus generator. So the generator method requires you to have an emergency generator with a life safety ATS, automatic transfer switch. So the automatic transfer switch and the generator must bring the egress lighting up to full illumination within 10 seconds. So once you lose power, that generator has to start up really quickly, immediately, and then has to get up to speed, meet the requirements for voltage and frequency, and the ATS has to switch over from normal to emergency, and the lights have to come on. All of that has to happen within 10 seconds. So it's a pretty strict requirement, and that will meet your egress requirement or egress lighting requirement if you don't use battery. The benefits of that are that you don't have to deal with batteries. So your maintenance is limited to the generator, and you don't have to go around the building trying to find batteries. One of the downsides is that another benefit is that all your fixtures are the same. So if you have like a type A fixture, you don't need a type AE for emergency. They're all the same. So it simplifies your design a little. Let me go back to the generator con. So the con is that you will have a momentary delay in your lights. So if you lose power, you could be without lights for about 10 seconds. And in some instances, that's not desired. So you have to make sure that it's appropriate for each space and it's appropriate for your facility. Certain places also require you to have like certain switching and controls. So when you bring generator power and normal power to a room, most of the time you're going to be controlling both circuits using one control. So when you have a power outage, your generator egress lighting fixtures, they need to come on at full brightness regardless of what the switch is in the room. So what I'm getting to is the control side of things, which gets a little more complicated. If you're using a generator to power up your egress lights, you typically need some kind of relay or like a bypass switch. And this switch essentially, under normal operating conditions, will switch off your emergency fixtures on and off depending on what your switch is doing. It'll read the sense on the switch and be like, okay, it's dimmed at 50%. Oh, it's off. And it'll switch it with the normal power. Now, when you lose normal power and the generator kicks on, this relay wakes up and it's like, hey, where's the normal sense? Like, there's a normal sense wire that goes to the normal circuit. There's nothing coming in on that side, and it detects that your normal power is lost. So then this relay goes, okay, I'm going to ignore all the controls from that switch and just turn this emergency egress fixture on at full brightness. That's a requirement of the code, and that's what's needed if you use your generator to power up your emergency egress fixtures. So that adds a layer of complexity to it, and you have to make sure you pick the right relay, you don't overload it, it's compatible with your dimming switch or your switch method, and overall it's just one more thing to add to your design. There's two different kinds of relay switches. There's one that will always pull power from the generator side, or there's one that's like basically got one input. Like you just run a wire that'll carry normal power and generator power, and your switching happens back at the electrical room. There's an ATS in there, and it'll switch over. There's another variant that takes an emergency only feeder and a normal feeder, and that will actually switch over on its own. So like if you have a generator that doesn't go on a transfer switch and it's just like emergency only panel, you can run a circuit from that to this relay, and the relay will decide for itself which one to use. So the load is handled a little differently. It's just something like that you got to pick up on and make sure that you include in your design if you choose between battery versus generator. Okay, that's enough for that. Let's jump to controls a little bit. So controls can be done either like through line voltage or through low voltage. So line voltage is anything that's like 120 or 277 volt switch. So like your typical toggle switch in your home, they used to be all line voltage. You can dim with that too. So you can have a resistive dimmer that basically decreases the amount of power that goes to your fixture. Those were fine for incandescent fixtures or halogen or what have you, the old technology where it creates a lot of heat and it uses line voltage. So that's slowly phasing out in favor of low voltage dimming, and that uses 0 to 10 volt dimming. Pretty sure it's DC, 0 to 10 volt DC. So this is just what we call low voltage, and it goes to like a little switch that only sees low voltage. You don't wire the 120 volts to the switch. You actually go to the fixture, and the fixture has these two little wires. I think they're blue and gray. They come down to the switch itself, and when you touch the switch, you can do like a momentary switch where if you just press it once, the light comes on, you press it again, the light goes off. Or I'm not really sure they have toggle switches anymore. They don't. Yeah, the low voltage switches are typically not toggle switches. You push a button and it just changes state from like a 0 to a 1, and that turns your light on and off. There's also dimming controls on there. So if you have like a slider or like an up and down arrow, that will dim the light through low voltage, and the fixture itself will handle how much power it needs between the power sources. So as you get into more switches, the use of 3-way and 4-way switches are really decreasing. Like without line voltage, you don't need a double throw 2-state switch. You don't need a 4-way switch. All these low voltages basically communicate through their own protocol, and all the switches are the same. So it's just a standard momentary switch at like 2 or 3 doorways if you need to. So that makes it a little simpler, and it's actually easier for the contractor to work on because you don't have to deal with your 120 volt AC. Then in conjunction with the wall switches, you'll have aux sensors. So occupancy sensors sense when someone's in a room or a space, and they'll turn the lights on and off. Occupancy sensors can also double as vacancy sensors, and the only difference is that vacancy sensors will not automatically turn on lights. So when you would use one or the other heavily depends on the energy code that you're using in this project. So the energy codes are IECC and ASHRAE, and these two are typically the only two governing energy codes in the United States. They vary slightly between each other. Like for one, I think has like a requirement that only certain spaces can use only certain spaces can use occupancy sensors, and the rest has to use vacancy sensors. And then the other one I think has like a little deviation from that. So you have to make sure that you understand which energy code you're using for your project and design your lighting controls appropriately. So yeah, not only do you have occupancy and vacancy, you also have photocells. So the photocell detects how much light is in the room and will dim how much sunlight is in the room and will dim your artificial lights appropriately. So that's called daylight harvesting, and is actually required if you meet a certain criteria within the energy code. I'm not going to go into the exact details of that because that gets a little confusing, but essentially you'll have your switch on the wall, which is typically required everywhere. You have your aux sensor to make sure someone's in the room, and if they are in the room, you have to make sure your photo sensor dims the light so that you're not exceeding like a certain light level in the space. So that's all fun. That's very much a lot of fun and integration. It gets crazier when you introduce like scheduling, when you have your wireless controls. Wall-mounted aux sensors are they stick out like a sore thumb. For some reason, wall-mounted aux sensors are typically line voltage, so you have to bring like your 120 to the wall switch, and then that goes up to your fixture. It's kind of annoying. I have seen some 0 to 10 volt wall-mounted aux sensors, but for some reason they're not very common. Then one little thing about the wall sensors is that they are only passive infrared. So they don't have ultrasonic and passive, and your ultrasonic detects like around a corner. So like if you have an occupancy sensor on the ceiling, that's typically dual tech. You have ultrasonic and passive infrared, and both of those work in conjunction to reduce false tripping or false positive, I guess. So they both need to detect something in order for the lights to turn on. Ultrasonic is good for movement. PIR, passive infrared, is good for body heat. So if you detect heat and movement, there's probably a person in the room. So if you're not moving and you're cold, then you probably don't need light. You're probably dead. But if you have heat and you have movement, then the lights will turn on. So that's nice to put in the ceiling. It's good for if you're in a bathroom stall, and you know how the stalls are blocking your heat signature. I think I typically put ultrasonic only in bathrooms because the ultrasonic sensors will detect like movement around corners. Like even if you're in the stall, it'll detect your little movement in there, but it won't be able to see heat. So if you're in the bathroom, you probably want the lights to stay on if you're taking along number 2, but you don't, it's okay if it stays on a little longer. So like from a functionality standpoint, I put ultrasonic in the bathroom. Then if you're in like a shower, or was it the shower? It's something about the heat. Was it by kitchen? One of these scenarios, you actually don't want any heat detection. I forget what it is, but that's getting too much into details. But like the wall mounted one, for some reason, it's only passive infrared, so it's only heat signature. If you point it like at the corridor for some reason, and your person's like sitting just beyond it, it's not going to see it. Like there's no ultrasonic to pick it up. So I don't know why. It's a little weird, but that's a wall mounted fixture. So yeah, there's so much going on. You could also do time clock. Time clock turns all your lights on and off at a certain time. I typically use that for site lighting or building mounted lights. Sometimes I put it for corridors, but most often I just use it outside. And then the last bit of complexity that we have to deal with these days is to tie the occupancy sensor for the lights in the room. We have to tie it to the receptacles too, because the energy code requires that, I'm going to say 50% of convenience receptacles in like open offices or like general use rooms have to be controlled by the occupancy sensor. So you have to call that out when you're drawing somewhere. When you have an aux sensor, it has to go to a controlled receptacle to turn that off too. So that's fun. Most of the owners hate that. I'm not really sure what they're trying to save here, because like it's just, maybe you had a heater on and the person leaves the room. Okay, fine, turn the heater off. But more often than not, people will try to plug in a laptop or a monitor or something charging, and when they leave the room, it's not going to charge. So that's fun. But yeah, you got to tie that in now. And the biggest challenge is trying to tie the overhead occupancy sensor in with pre-wired furniture. We did it through like a power pack that basically shuts down 25% of the circuits to the desk, but then the manufacturer themselves they don't really know which 25%, like how do you circuit 25% of the receptacles? Sometimes they'll take that circuit and only run it to one desk. So just that desk in particular gets completely shut down, and it's not great. So it's a kind of a work in progress. They have these receptacles that are like individually wirelessly controlled, really expensive, but basically you put them in the box and that wirelessly communicates with a box up in the ceiling. And once the box in the ceiling finds out that there's no one in the room, it'll send a signal out to shut off those receptacles independently. But my thought is that receptacle still has to be drawing some type of phantom load, right? Like it's got to be on, it's got to be listening. So how is that any better than just having a regular receptacle that's not used? I don't know. A lot of stuff going on. Okay, so I probably rambled on for about a half hour. That's a overview of lighting. This might have been better as a podcast, who knows, but hopefully you found this interesting. Apparently I could talk on forever about this, so if you want to know more information about any particular one of these subtopics, drop a comment in the description and I'll go into more detail on that. So I think this is going to be useful for some people. It's kind of like a like when you're in the office and you just want to talk to someone about some general topic and just like this high level information. I don't know, it's kind of nice. So maybe I'll do this for other topics, like if you want to talk about, I don't know, panel boards or, you know, fuse disconnects or some crap like that. Let me know what you want to hear in the comments, and I'll talk to you guys next time. Thanks for sticking around. I'll see ya. Bye.